No. Okay, cool. Yeah.
Okay. Okay, so start. Hi everyone. My name is Thinh. I am a PhD student at UniMelb. It was just an honor to be invited here to give a talk at Oracle. Nice to meet everyone. So today I will present a recent work of mine. Actually, not that recent. I did this like at the beginning of this year, and the title is about is language model are not naysayer. Sorry for the clickbait title. Okay, so as the name suggested, in this work I will show an analysis of a language model on negation. And this is our work that I did with all my, so here are all my supervisor. And as you can see, they kind of left UniMelb already. So I don't have any active supervisor now, which is unfortunate or fortunate. I don't know. Okay, so for today, there's 4 things that I like to discuss. So the first is I will provide some background, so like introduce why is negation an important task that we need to focus our attention on, and then I will go through like 3 different aspects of negation that I would like to introduce you to, and as well as showing the performance of current modern NLP methods that are using a language model. So let's jump right in. So this is a very nice sample that I kind of show at everywhere I present about negation. So so for example, you kind of have some kind of condition, and you go to Google search, which you should not do, but that's everyone has been doing anyway. So Google return to you like a very nice summary about some medical advice, and they also cite like a very credible source here, and it's look like very believable, and it make a lot of sense to a layperson like me. I don't know anything about medical knowledge, but actually if you go into this website, and you can see that there's a very nice heading like "Do not here." So if like a person follows the advices like blindly, they would likely be dead. So that's it. So yeah, like, so that is like the main kind of motivation I got for my research. Okay, so moving on, I will introduce some really some previous work that people have been doing in negation. So first of all, people have been looking at the common NLP benchmark like glue or super glue, and they try to find what kind of negation are in those benchmarks. And the first finding they find is that negation are kind of underrepresented in those benchmarks. Like here you can see like they are like varying from like below 1% to like 25%. And in general English, the percentage of negation are kind of around 30%. So we can say that they are kind of underrepresented in those benchmarks. And the second finding people have made is that the negation in those benchmarks are kind of unimportant. What I mean is that we can safely ignore the negation in those sample, but still can make the correct decision. So for example, in this sample, we can kind of ignore the phrase like because the plan did not seem very good, and we can correctly infer the relation between those pair of premise and hypothesis. So they are unimportant. And the last finding is that negation in those benchmarks are kind of simple in terms of how they are represented. Like most negation are simply adding the word not to negate the main predicate of the sentence. and that is not kind of good, because if so, we can understand a sentence very simply, and so on the current NLP method can do so too. Okay, so moving on is about the impact of negation in NLP tasks. So again, a previous work have shown that current models struggle when the sample, when the input presented to them contain negation. So one possible reason is because how those models are trained. So we can see like a very high similarity between the context of the sentence without negation and a sentence containing negation. So for example, probing task try to probe a language model. So here they use BERT and they provide them with a pair of query, one containing negation and one does not. And we can see that the top prediction in both cases are kind of similar. So we can say to some extent that those models do not actually understand negation, but they just follow common pattern. So moving on, because they are kind of similar like this, they have very high similarity in their representation. This affects a lot of other applications too. So like for example, in semantic search, if you somehow search for a query, but the query contains negation, then the result are like this, like they are not able to understand that we are interested only in on the product without some property. So here is an example that I just tried like a few hours ago on Amazon. And another thing is that negation has been shown to be a common and effective adversarial way to construct adversarial sample. Like if you, so in sentiment analysis system, if you replace work with kind of like a paraphrase version of the work, but the paraphrase version contain negation, then the model will likely fail to infer the correct sentiment of the sentence. Here is example. So spotless here is actually a word carrying positive meaning. And finally, negation is also have been shown to be a common error for summarization model. So I give an example here. So this is like a radiology report. So in those kind of text, there's like they contain a lot of negation, because this is like the this is what the doctor or clinician write in their report when they look at an X-ray image. So they contain a lot of negation, like this image does not have any abnormality, does not have any tumor or something like that. And as a result, the generated summary will likely contain negation too. And the challenging part is like how do the model understand what is actually negated in those in the original document. So yeah, they can produce like contradictory finding compared to the actual summary. Okay, so that is the end of the background part that I want to introduce you to, as in why negation is so important and what has been done in the field. And previous work has strictly focused on pre-trained language model, like smaller one like BERT, and whereas the finding hold for large language model or autoregressive language model, like there's no work that do that before. So in this work, I want to evaluate their performance in a zero and few shot setting, because we are doing like large language model, and we are, this is like the default way of evaluating those models is through prompting. And here I just collect like existing negation benchmark, and I categorize them into 3 different aspects of negation. So the first one is whether they are sensitive to negation, and I use factual statement for this sensitivity test. And the second one is about lexical knowledge of negation. So by lexical knowledge, I mostly refer to the relation, so the antonym and the synonym relation of word, because negation is not just they can not only be expressed through syntactic negation like not, but they can also be expressed through lexical way, like if we have a pair of a word and its antonym, then in this case, this is also a way to express negation. And the last one is about negation reasoning. So, the way I do that is that I collect different and natural language inference benchmark, which focus strictly on negation. I will introduce in detail these 3 aspects when we go into each one. Okay, so about the experimental setting. So as I said before, at the time that I did this work, there's no like current class of model like llama, and I mean now everybody has been using something like llama, alpaca, but at this time there is no such thing. So I just use whatever is available at the moment. So so for open source model, I use GPT Neo, OPT from Meta. And for closed source model, I use GPT-3 and GPT 3.5, which is Text DaVinci 003. If you use the OpenAI API, then this refers to that model. And I also experienced with another open source model that is Flan T5, and to show the effect of instruction fine tuning on the ability of model to understand negation. And again, this is I just do zero and few shot setting for those type of tests. And again, and yeah, no fancy prompting technique. Like most tasks, I just do it through direct prompting. So I didn't do chain of thought prompting. Okay. Okay, so moving on to the first test. So as I mentioned before, the first one is about negation sensitivity, and the intuition is as I saw in the example before, like we are trying to look at the prediction of the model on 2 types of query, one containing negation and another does not contain negation. And if we see that model provide similar prediction to both of those query, then we can conclude that they are not sensitive to negation. And the data set that I use here is called mass knowledge retrieval of negated query. And the way that they constructed data set is that they just collect triplet from ConceptNet. So ConceptNet is like a knowledge graph contain triplets that have entity and relation that deal with common sense and factual knowledge of the world. So it's something like ibuprofen is a type of drug or medicine. And example in the data set look like this. Yeah, ibuprofen, and there's a negative relation, and then some wrong completion. So we have wrong completion here, and what we want is that the model should not predict any word in this wrong completion list, because this wrong completion list is the correct prediction for the non-negated query. So how do we actually evaluate this type of task? Like, because we are trying to to measure the prompt completion. Like we are trying to see if the model wrongly predict those work in this prompt completion list. So the way that I measure the performance of the model is that I would try to calculate the match between the prediction of the model and the list of prompt completion. So this is like a lower is better metric. And so this is the equation. So basically, so X is the query and W is the list of prompt completion. And CI here is just basically the prediction probability of the model. So, and basically if the model predict a work in the list of prompt completion, then we just take the probability and then just normalize. So basically, for example, we would take the top 5 prediction of the model and then try to see in this top 5 how many times the prediction match the work in the prompt completion list, and then normalized by the prediction probability. So this is so this metric have a lot of limitation because obviously we do not have an exhaustive list of prompt completion. So what I mean by exhaustive is that there can be a lot of cases where the model predict some work that are not in the list of prompt completion, but instead it's a synonym of the work in the list of prompt completion. And in those cases, the model, obviously we can see that the model provide a prompt completion, but we cannot evaluate them. And another problem is that sometimes not prompt is not equal to correct. So like the model can produce some garbage work. Like for example, if Purofan is not something like, obviously it's not a if it produces if Purofan is not a medicine, then obviously it is a prompt completion. But maybe if they produce something like if Purofan is not animal, for example, then we can see that the prediction is not related at all. And in those cases, we have no idea to how to eliminate those cases. Okay, moving on. So here is some prompt that I use for this test. So the default prompt is just the original sample. And here is some other type of prompt that I use as a way of like an ablation study. So contrasting here means that I provide a non-negative query as well as the correct completion. Discourse here is that I just add a discourse marker into the sentence to make it sound more natural. And mask here is like, this is an attempt to remove the internal knowledge of the language model. And the intuition for those ablation is that I want to measure whether the model is able to differentiate between the two contexts, or they are very easily distracted and they will just repeat whatever is provided in the non-negative query. And the result is okay. So as I said before, this is a lower is better metric. And for the default prompt, we can see that the performance gets worse when we increase the model size. So this is called inverse scaling. And recently there's, yeah.
The size normally with the emergence probability, right? So for example, the probability between zero shot just count certain size on it. But this field of manipulate, meaning the model gets bigger and
Yes.
Why? Why?
One reason is that I guess larger model tend to memorize the training data more. So that's why I mean, if they memorize the data more, then they just repeat the common pattern found in the training data, and which make the model kind of like insensitive to negation. So that is one possible reason that I can think of, and this has been shown before in. If you are aware, there's like a competition called the inverse scaling prize, where they propose like different type of tasks and capability. That's large language model have shown inverse scaling trend.
One question: all this different size, same model or different model?
Yeah, this is from the same model. So this is the result for GPT-Neo, and for OPT, they kind of follow the similar trend. So I did not show it here.
So the model size is different. How does it
training data is the same. Yeah. No, same training data. Yeah.
But for more iteration, usually for more iteration or the same iteration?
Well,
because usually they go with more iterations.
I am not so sure about the training step of those model because normally I guess to do this kind of comparison, like people should like fix everything and just change the model size in order to compare between them. So I guess that's so I guess everything must be the same, just change the size.
Because if the model size is different, but data size is same, then the result is quite different. Because basically, when you have larger models, you're supposed to train with more data. Otherwise, I mean, I don't mean like overfitting what happened here, but generally, as you said, possibly just remember more of the pattern in the same data. But if we have more data, means that possibly the large model should have better capability in general. But the thing here is the data is limited. The size of the data is the same.
Yeah, the size of the data should be the same. And okay, so that's one result, and we can, yeah.
They're talking for this whole graph, are they the components of one single model? Because the color seems representing the metric, right?
Yeah, the color is the metric. So the so this graph refer to the same model, which is GPT-Neo. Yeah. And the x-axis here is the different size of the model that I investigated. Okay, so another one more interesting finding here you can see is that when you add some context into the prompt, so here I explicitly add the non-negative query.
If your assumption is right about the way you fit the data better, right? Like because the smaller model more better, and you think that it's overfitting the bigger model and memorize the data better. You can verify that pattern consists by just testing with say llama 1 and llama 2, right? Because llama 1 and llama 2 have the same, you can pick the same model architecture, same number of parameter, but if the tool doesn't train on 40% more, and because of that, it can verify. Is that interesting?
Yeah.
So if you say that actually training more on data, that what mean the data itself is a problem, and you can't fix the problem with more data. But one difference, another difference between normal and normal one is that not necessarily. And at any point in your presentation, you talk about the way to improve this.
Actually, actually, I didn't propose any strategy in this particular work, but I have done some work relating to improve model robustness on negation before. So maybe I can. So maybe or for PLM only.
So for that slide that you have the context there, right?
Yeah.
Have you tried to add some like incomplete learning numbers? Like say, something is not a medicine, but it kind of something, even kind of something, but provide a few examples there, and then see what the conclusion would be like. The current is kind of like the bill shot.
Yeah. I actually have been doing that in the work that I am currently doing now. So yeah. The finding is actually the same. Like they don't actually learn to follow the example that we provided. Yeah.
Sorry. Yeah. So the first one is regarding the default form. That's fine.
Yeah.
Based on this one, we can see that if for bigger models, there are more instances of engagement. But for the other ones, right, for contrasting this one and the other ones, that you are kind of framing the problem in a different way. It seems that the size doesn't matter. And sometimes they are getting better with the second one.
Yeah. They are actually getting better, but if you can see the scale in terms of result here, like it's have a huge jump in the score here, which suggests that it significantly get worse. Yeah.
One question here is that how many different kind of forms of framing have you tried? So here we can see 4 of them, but in your own internal evaluation, how many different forms or different kind of reframing you try to compare?
I mean, like because we have like 2 different kind of tests, right? So for default prompt, we kind of trying to see if the model can answer a negative query correctly, and for the other 3, we trying to see whether the model is distracted by a given previous context. So for the default for the first setting, I also try to I actually don't remember how many type of prompt that I use, but I try to change the wording in the prompt like several times, but just doing it very intuitively. So there's yeah, they are kind of the same pattern. And for the second type of test, I just use those 3. Yeah.
What's the WHR is calculated?
So the WHR is basically just the match between the prediction of the model against a list of given wrong prediction. So if they match more, then they are worse. Basically that. No, they are given. So I just use an existing data set. I did not construct this data set, but they are existing. Yeah.
and then the low confidence better.
You mean lower score?
Low confidence because you're saying it's a negation test, right? So
This one. Yes.
I'm just wondering, is it relevant to the selection of the words as well? Because in positive and negative, right, it's
Mhm.
not like really balanced. So there's less words that's like really positive, and negative is a larger chunk. And depending on the, I'm not sure whether I fully understand, you know, the way to evaluate if that's the way that's, you know, how I understand it. I think selection of the words also matters.
Possibly, yeah, because the larger model maybe has the capability to say a synonym or something, like because this diverse, like, it might not say the obvious thing, but it's still says the same thing.
So it means that it's in the favor of the larger model.
It's not, because there's a list, like whatever, and the chosen. I mean, it depends on how it's chosen in this, like the way, like, because you correct me if I'm wrong, but you have a known sort of list of potential values or something, right? For that,
Shouldn't be.
Yes.
Wrong.
with the wrong ones.
Yeah.
Exactly.
I mean, the English model suggests synonym is like the higher position, kind of worse. So it's kind of lower bound. Because it can become even worse, even have more synonyms.
Okay, so we just want to take the 5 top.
Yeah, I just measure the top 5 prediction. So here are top 1, top 3, and top 5 prediction. Yeah.
Sorry, that means in the data there's only 5 words in there.
No, it's more than 5. Yeah. I mean, it's vary between query, but all of them have more than 5 wrong completion.
One question, how do you look at some of the errors from different models? Look at just very specific examples that, for example, the 125 million model did correctly, but the 60 million model made a mistake. Have you looked at some of them? Was there any pattern of mistake there?
I guess mistake is just they just hit the wrong completion more. And aside from that, there's no other interesting pattern, I guess.
On the top one, sort of increase the WHI increase for the other prompting, right, compared to the default. So, like, I assume that it's the same scale.
This is different scale.
But
Yeah.
magnitude, right? So
Yeah.
that's 125 is 0.8. The 125 WHR1 is like 0.04.
Mm-hmm.
Because the contrasting one meant to be sort of like easier.
You mean easier because they are giving more context?
Yeah.
Yeah, but actually that is not what we observe in those cases. So we kind of can conclude that they are prone to repeat what is given more than understand the difference between the negation and non-negation context. Yes. So this is one example of like given more information is not always lead to improved result, but more information can potentially act as a distractor and would degrade the model.
no.
Sorry. Any question from online participant?
Okay, you say no. Yeah, that's continue.
Okay. I guess I should continue.
Yeah, I have a question. Yeah.
Yeah, so
Yeah, so have you compared the, the error rate if you change the negation to like the positive, right? Have you compared the difference? For example, broken is a type of something, right? For this kind of sentence, what's the error rate and how does it compare to the negation one? Is there any large gap between the if the prompt is a negation or the prompt is not a negation? There is
right. I don't have the result in this work, but actually because this is an existing data set, then obviously they already have the result for the non-negative query. Yeah. And the conclusion from the other previous work that deal with non-negative query is that the performance is very good.
very good.
Like they can match the correct prediction, like, and they can, like smaller model can already do that. Like if you use BERT, then the performance is already very good for those non-negative query.
So accuracy for the non-negation result is very high.
Yeah. Okay. Okay, so the second test is following the same kind of evaluation scheme and the same format. So it's also a close completion task, but this time it is not about factual statement, but this is about work relation. So basically asking whether what is the antonym of a work. So there are two settings here. So the first one is a close completion task. It's also following the same format. And the second task is a classification task. So in this case, instead of giving a query for model to complete, we are giving a pair of work. And then we ask the model to predict the correct relation between them. Okay, so the data source is on in ConceptNet. Okay, so once again, I also propose like different type of prompt. So they are kind of very intuitive, and like there is no fancy way of prompting. So like once again, the default prompt is just the very simple sentence. Quote is that I try to add the work into a quote here. And for classification, we have some other prompt like symbol, like I change the wording, like instead of using antonym and synonym, I kind of use more simple word like opposite and similar. For negation prompt here, I explicitly explain what is antonym and what is synonym. And yeah. Okay, moving on to the result. So once again, for default prompt, we also kind of observe an inverse scaling trend here. And for cold prompt, they kind of, once again, the result get much worse. And it gets better when we increase the model size in the cold prompt. But so based on the result, we can see that the model kind of understand the relation between antonym and synonym. But when we observe the performance of classification tasks, like we can see that the results are kind of very random, like they just fluctuate between 0.5. So based on those results, we can kind of conclude that the model do not actually understand the what is antonym and what is synonym, but they kind of just once again they just follow the pattern that they have seen before. Like if we ask them to provide a completion to a query, then they kind of do it quite good. But if we just ask them to do a classification task to predict the relation between two words, they don't actually understand what is synonym and what is antonym. Yes, sorry. Yes.
Instruction tool models will do better.
Yes, I also help result on instruction tool model, but we will come back to that later. Okay, so the last time of test that I did is about reasoning. So here is I shows here 3 different data set about NLI, which focus on 3 different type of negation. So the first one is about verbal negation. So by verbal negation, I mean that the negation kind of associated with the main verb of the sentence. So they are kind of very simple. And the way that they construct this data is that they collect sample. Oh, sorry, there's a question in chat. Could it be an
Can you speak that? Yeah. It's a bit small. Yeah, you just speak it loud. Yeah.
So the question is, could it be an emerging property that show up for larger model size? So by emerging property, you mean that the property that they are doing worse with negation when the model size get larger? So I guess it is similar to the assumption that I made before that larger model tend to memorize the data more. So yeah, I guess that can be considered an emerging property.
Yeah, just continue that.
Okay, so going back to the first NLI data set, so they just collect sample from commonly used NLI data sets, and they just add the negation Q not into the main verb of those sentences. So for example, here they just add the not here associated with the verb sitting. So those kind of tests, the kind of sample are kind of very simple. So, and the second data set is about subclausal negation. So by subclausal, I mean that only a part of the meaning is negated. So here I provided some example to show what I mean by subclausal negation. So in this sentence, you can see that this is a negation associated with a gradable adjective. So when you say not wholly convincing, like it does not mean that there is nothing convincing, but there is the story is convincing, but only to some extent. And to correctly understand the meaning of this premise, I constructed like different hypotheses by making a minimal edit to the premise to form like different hypotheses. And as you can see that for this sentence, for example, if you switch the position of not here into something like wholly not convincing, like it become like completely contradictive meaning. So basically it was meant to show that when you switch the position of not in those kind of cases, in those subclausal negation, then the meaning of the sentence can change very drastically. But the similarity in terms of lexical form is very minimal. And here is another sample that deal with quantifier. So for example, if you change not 1 here into some other modifier like sum 1 to 20, for example, and it is a very minimal change, but can change the meaning of the sentence very drastically. The last type of NLI is kind of very interesting. So this deal with hyponym and hyponym relation. So here is 2 examples. Like if you consider a pair of hypernym like dog and animal, like dog is a type of animal, right? But when the pair of sentences does not contain negation, then we can we can infer that a man owns a dog, infer that a man owns an animal. But if we add a negation to those kind of cases, like for example, a man does not own a dog, does not actually entail a man does not own an animal. They can own some other kind of animal we don't know about. So again, this is kind of like making minimal change to the pair of sample, but changing the meaning of the pair very drastically. And again, this is some result on those kind of data set that I just introduced. And we can see that the performance in most cases are just lower than random. So for three class classification, we have lower than 0.3, and for two class is lower than 0.5. And we can see that scaling up the model size almost has no effect at all for those NLI data set. So once again, because
you mentioned the experiment with GPT-3 as well, but the numbers is GPT-3.
yeah, I will show the result of GPT-3 later. And once again, the possible reason for those NLI tasks is like very low, is that the format of those tasks is that they contain like two disjoint sentences together, like they are kind of not related at all, and the second sentences are kind of not the continuation of the first sentence. So the model are kind of very less likely to see the kind of pattern before in the training data, so they kind of perform worse. And again, this is a very kind of hard task, and I guess most model would require a substantial amount of supervision to be able to perform those tasks. Okay, so result for few shot also, and there's not much improvement for few shot either. Okay, so finally, this is some result for those larger and more competitive model. So we have GPT-3, and compared to the best model before, they do actually improve. And if we use GPT 3.5, at this point in time, they call them Instruct GPT, but nowadays they just call them GPT 3.5. And yeah, GPT 3.5 performed the best. And like you can notice the result improve very drastically compared to reverse model. One interesting is that they did not perform better on the last NLI data set that deal with hypernym and hypernym relation. And here I also have result for an instruction tune model, FLAN-T5. They are kind of very competitive, and the results are comparable to GPT-3. So we can say that more than just scaling model size, like different fine-tuning strategy also play an important role, because FLAN-T5 here is like 11 billion parameter, so it's like 16 times smaller compared to GPT-3, but the performance is comparable. So the next slide is like I try to have an assumption on why the model perform worse on those data set contain hypernym and hypernym relation. So I guess well, we can say that the model like can have an inductive bias in that they learn a correct reasoning step for the non-negative sample and apply that reasoning step to negative sample. So if you look at the output of ChatGPT here, you can see that they apply the same reasoning to both query. So I guess that can explain why ChatGPT didn't improve the performance on the data set that have hypernym and hypernym. Okay, So the takeaway of this work is that I measure the performance of large language model on different aspects of negation. And for negation sensitivity, we can conclude that they are sensitive to negation, but are also very easily distracted by changes in prompt. For lexical knowledge, they also understand the relation to some extent, but also depend on how we frame the task. Like a completion task would perform better, but if it's for classification tasks, that they don't perform well at all. And for negation reasoning, those models are still lacking in many aspects. All right, yeah, that is the end of my presentation, and thank you all for listening.
Question, I think, more or less got this question. Negation is an important problem to solve, right? We see the same problem in the LLM. And when you work on medical domain, right, cancer, positive or negative, might change a lot. So that's why I think and this only just sort of like suggestion idea or I want to discuss, right? But based on what you just mentioned, first is as explicitly having this as part of the prompt, improve performance, right? So you can upload it by having a more reasoning capability, like in the part or the part, for example, likely it will have. That's one idea that I think we should try. The second is it seems that the model that can reason well would be the model that likely to perform better communication. The model reason well, likely the one that trained the book. And it sort of makes sense for me because in the language, right, with distribution of hypothesis, the distribution between happening positive and are similar. But for programming language, very different, right? The association between, say, the code and the description of that code are very different for positive case and negative case. For example, right, when you want to like something not something, right, it will always have a tilde or something like that. So the programming language will reflect it very well. So no confusion like normal language.
True.
So likely, and this is just my hypothesis. And if you test it and you show it, it will be great. I want to know the result, but I think that likely that you test the model that specifically for code like the star code, for example, can potentially perform what I can do. So that's also something easy to try. The next thing is find the model, but fine tune it on the task sensitive to relation. You just show a bunch of different data set, right?
Yeah.
But you really need to reason over negation and just have pull out text set a couple of tasks and fine tune on the other tasks. And the other task that I think can be useful is sentiment analysis. Because for sentiment analysis, right, that we use quite a bit of negative what dislines is or something like that, and the model really need to disambiguate well overall semantic of the sentence with the negative word in order to classify it well. And for semantic for sentiment analysis, you potentially have the access to like the model data, right? For example, like product review. From internet, there are a lot of product review, and from the product review, they have the star rating. So from star rating and product review, you can extract like millions of those similar data for sentiment analysis, and that might be a very good source for you. So I just, if I were you, that's what I'd like to try. Because for all of these models, likely that because the model is so big, likely that like a lot of training data would be needed to change some fundamental capability.
Yes.
So there are paper, I think, from Meta mentioned that you can change the you can introduce the new sort of capability which is like 1,000 instruction item example just for 1,000, but it's more or less reshaping the output, not introducing new capability. And it looked like that the negation is the understanding negation is the capability that missing from the base model. So that's why I think to effectively resolve it, you have to have a lot of training data. So that's why training on code or training on the sort of tasks that we need to disambiguate to positive and negative, like the sentiment analysis that I just mentioned. Likely would happen.
Yes, thank you. Thank you for your suggestion. Yeah. So basically just like create a new instruction data set that focus on negation as well as.
And likely that needs to be big, that is big.
Right.
It's really difficult. Because people ask me a question and want the answer to this question. Is it really the case that negation is something that is missing in the base model? I understand based on these results we can say that, but can we actually say that? Because we saw that with the instruction pointed model, the negation was better. It was much better. Do we really need? So that's why I suggest that the third step, right, the first and second, just simple thing in instructing like chain top or tree on top, for example, to verify that we cannot even when you even with all those fancy prompting techniques, we cannot solve the problem, then we go to find it. Yeah, I agree because it might be somewhere there, right? And also in these results like this, the one that you see is that just for conclusion as how about the summarization? If you use a smaller models in a larger model, how do they perform in the summarization? Handling the negation in the summarization for sentiment analysis, just in viewership model. And very likely the problem would get worse and worse when you have a bigger and bigger context. Because the chance that attention and attention market to redistribute that focus on a single key, like what that containing innovation would be a lot smaller.
So the models like GPT, like 3.5, I mean, reinforcement learning, like the reward for positive and negative things, like very big. Right? So if they were potentially, that could be a reason why it's slightly better sorted.
That's actually a very good point, right? If they for summarization task and to mess up negative and positive, likely when the like reinforcement learning like ranking, right, it would be like very big score and small score. So that's why potentially the task that if you train with the reinforcement learning. And this also might be the reason why that 192 focus a lot on reinforcement learning.
Maybe, I mean, what you mentioned before is like there's a big risk with like an error, right? If you do like cancer in positive and negative, so you only need one error from your model to get like a big drastic outcome. So for me, it feels like getting more data into with the models is only part of the solution because never gonna get 100%. So I think a lot of it is also trying to see if you can imbue the models with a way to warn us when we doesn't know. So we Right.
So couple of solutions there, right? First is us always having human sign off. So you summarize for doctor, right? Doctor need to sign off there. That's the human in the loop likely is the best solution. But if the doctor sees your output that mess up positive and negative like that, right? Doctor won't trust your model. That might be the end of your product, because they couldn't buy it. But you raise a very good point, like model explainability and model sort of like confidence in terms of it. But right now, I think if we get the output from large language model, very likely and it's very confident. 100%, most of it. That's actually a good point. That how you build a well calibrated large language model.
One of the use cases working on also is self-consistency, because the technology can usually as self-consistency, and also another model, another kind of critic. Look at it, we can usually validation is easier than the generation, so we can have another model. And also we might reframe it, because the research shows that the reframing also might change the output of these LLMs.
The thing is like, as long as if you assume it's going to be all, you have to rely on your data to learn negation. There's always going to be border cases that are going to be very infrequent that a model like this. Right? So that's the risk, right? And so either, I mean, it doesn't sound like an old professor now. Maybe it should have to be a rule-based model to deal with that, because then you don't have frequencies for rules. But or you should have a way to say like, I never seen this pattern before, right? And that's already right. And it might be just fine, but at least it's the red part. But because I feel like, especially like the examples that showing that they some of them they give you a little bit contrived, but at the same time the risk is like if it happens once and it gives you like that outcome, then you know. If I don't know, I feel for me like I don't know, maybe the solution somewhere in between, like not stop real. I mean, sure, we can get more and more data, but I wonder if there is a pathway to stop relying so much on just the data and try to do something a little bit more. Whatever, I don't know.
There's the other way than like human in the loop in the end have a side off that. I mean, for the negation, you can have a sort of like fact checker, right? That for every piece of evidence that we generate, that we come back and check for something. That might be, and it does come back to what Tuya mentioned, right? That self-reflection can have two LLM, one LLM just doing the generation and another LLM which just be another way you can do that. If you do that through many iterations and through a lot of like, if you do 100 iterations of fact checking and all 100 iterations that with 100 different LLMs, they all say you are good, then likely that you are truly good.
Well, maybe I feel it's a long way to go. We're actually going to full autopilot track. It's going to be on autopilot for the moment. It has to have human input. Otherwise, as you said, it's just a huge risk.
The other thing is about the psychology and the people, right? So as a person, right, we might not accept an error from the model, but it's easier to understand mistake from the physician. There's a lot of legal cases in US regarding the malpractice. But you know, if there is only one case using AI, like Tesla autopilot, you can see there are some accidents. But if you compare it with the normal people, the broad people that are in the accidents, it's much higher. But you know, from the different Our psychology that we can like, because it's kind of, we don't understand.
Might be the same for machine learning engineers, we should accept that the ChatGPT to do the machine learning engineer for us instead of having human machine learning engineers. Yes, we accept the human errors.
We
I
want to
mean,
get us out of
It's,
that.
I don't think it's, I don't think one justifies the other. I think these are two different problems, right? They're both problems and they're both things. One of them, we don't have expertise with the data side. We only have expertise with the AI side. So
I think let's
Yeah.
go outside, then we go outside.
Okay, yeah. Thank you everyone for joining and let's wrap up this recording.